thanks for joining us on a Saturday afternoon. So happy that you could carve out some time for us today. So I'm just going to go through our questions that we've discussed before, and I was wondering if you could share a little bit about how you were attracted to audio. Now, I know you grew up with a father that was speaker designer, very into audio, so I'm guessing that piqued your interest, but it sounds like you had a whole career before you came and circled back to you restarting Janszen Speakers. So what piqued your interest? What made you decide to do that?
Okay, well, I'm going to rewind back to the beginning of the story you started. My dad had a long career before he invented the first, well, he was the first guy who figured out how to make a practical electrostatic loudspeaker. And he did that not because he was interested in audio so much, but because he needed an accurate transducer to test the hydrophones for a project he was working on at Harvard, which was making torpedoes that could home in on the propeller sounds of the U-boats during World War II. So he developed this electrostatic speaker, and the war ended and the lab was winding everything down. This is at Harvard, their so-called underwater sound laboratory. And he realized it would make a really good speaker because none of the speakers of the day were able to reproduce transients accurately. So he figured out a way to manufacture it, patented that, then patented another way, and started up a company called Janszen Laboratory in North Cambridge, Mass. He wasn't sure if he wanted to do that. He already had a little company that did magnetics, transformers and stuff like that. But apparently, according to my mother, when she was in recovery from the cesarean, when I was born, she's still in the hospital, and my father danced in and said, "Hey, honey, I'm going to start the company," and which was a shock to her. But anyway, she got over it. She and my father started this company, Janszen Laboratory, and because I grew up with electrostatic speakers, it's the only sound that I think is accurate and sounds nice and natural and everything else. So yeah, when I was a kid, about when I was 5 years old, my father allowed me to operate stereo, which was a pair of KLH9s, a turntable that he put together from a Garrard turntable itself, which was separate from the tone arm, which was a Reco-Cut. Both were quite good in their day, and I think a Stanton cartridge, but I'm not sure. Anyway, he let me play records on it whenever I wanted, which was pretty nice. So I don't know, for my whole life, I really liked music, and I really liked listening to it and going to see it and everything else. So as you pointed out, I had a career before I restarted the Janszen brand about 15 years ago. And frankly, I was just tired of being the creative guy who would develop the new product for the company or the new version of the product or a platform for a company that could keep them sailing on for some period of time. And when you get done with a project like that, I got a good salary, so I became an expensive line item that they didn't really feel needed anymore. I got tired of that sensation, so I thought about what I could do, and I prototyped an electrostatic speaker. It sounded good, so I decided to give this a try. The product I came out with, I called the Model 1, and I would have had to sell it, well, I tried selling it for $38,000 a pair. Of course, my company wasn't branded Luxury Lifestyle. I couldn't sell them. Dealers couldn't sell them. I wound up selling my prototypes, sort of fire sending them through a distributor that I won't mention his name, but probably all know of him. And a comment I got from I had two comments from a dealer in New York. One was, "Is that as loud as they go? Huh, a gigantic intimate speaker." And the other comment was, "They don't fit under a windowsill in a New York City apartment." So I set about to design something more affordable that would fit under a window and sounded nice, and that was the floor standard that we still make, although in a vastly improved version. It was something I sent off to a reviewer for positive feedback. I'm sorry, I don't remember. I don't think it was positive feedback. anyway, there was a nice review in a webzine. I got 10 phone calls and I closed 9 sales from those 10 phone calls and thought, okay, this business has legs, and I made it official. That was in 2006. No, wait a minute. 2006 is when I started the whole thing. 2009 is when I realized between my branding and 2008 financial collapse, I wasn't going to be able to work it that way. So yeah, I guess that might be some history. My attraction to audio is just because I play music and I love listening to music, and it was just a natural thing to do.
Awesome. I mean, it must have been wonderful to grow up, you know, in that business, learning from your father. I did have a question for folks on the phone. How many of you can hear clearly? I know some of you putting on headphones and things like that. Can you hear? No, you can't. Okay. Is there, I'm wondering, David, do you think there's a way to turn up the microphone? I know there's an option in the audio.
It wasn't audible.
No, we can hear you, but they say it's a little muffled. So.
Okay. How do I, where is?
They're not dipoles, and the reason for that is the back wave from a panel speaker, a dipole speaker, tends to light up the room really heavily with backsplash and side splash from all the walls, and there's a lot of local ambience. And when you have that, you get this nice big sound everywhere kind of a presentation, but it makes it feel like the instruments and the performances have been brought into the room. The image isn't very tight. It's not a clear focused image. And what I personally prefer is to have a sensation that I've been taken out of my room and into the venue where the performance is occurring. And the only way you can do that is to minimize the amount of local ambience that your brain convolves with the recorded ambience. So that's my reason for closing the backs and just soaking up the back wave. I have taken, this is one of the panels that's in our speakers. There's one of these in, I don't know, you can probably see a pair of speakers back here. Those are our stand mount speakers, and I'll talk a little bit more about them. And there are 2 of these panels in the floor standers, and there's one of those in the way back over there. It's black. We had someone order them in piano black, first time ever, and well, there they are. So anyway, these panels, as all electrostatics, have an electrode on both sides of the membrane. There was a time when some electrostatics were made that just have one active electrode and a membrane, and they won't get very loud, and they have a lot of what's called sine squared distortion because the force varies with the position of the membrane pretty strongly compared to if you are pushing and pulling from both sides. Well, one side is pushing, the other side is pulling on the membrane. I don't know if you could see, I don't have a clear picture of myself up there, but I guess you can see there's a reflection from the membrane, and on each stator, these are called stators because they don't move. There are 66 little wires. They're all connected together on one of these, and they're split electrically down the middle on the other one. One of the problems with a really, you probably don't think this is a wide panel if you're used to a moon or something, but when you have a wide transducer, it tends to focus the high frequencies into a really narrow beam. One of the criticisms you may have heard of electrostatics is they're beamy. What I did to deal with that is, I think you could see that there are 4 terminals on here. There's a front terminal, 2 rear, sorry, this is the back. There are 2 rear terminals on here. There's a front terminal and a bias terminal. The bias terminal is to put a static charge onto this membrane that can work against the alternating charge on the stator electrodes. Anyway, by splitting, Paul, did we lose your, there we go. By splitting this electrically down the middle, my circuitry keeps the very high frequencies out of half the width. So there's a narrow width covering the high frequencies and the mid-range frequencies. So at the high frequencies, there's a wider dispersion. The wider the panel, the narrower the dispersion, the narrower the panel, the wider. And then the entire panel does the mid-range. And so those two dispersions, which vary with frequency, overlap each other. So in the range from about, well, these cross over at 500 hertz. So from 500 up to about 10 kilohertz, there's a 20-degree horizontal dispersion within which there's very little difference in the frequency response. And there's some droop in that top octave from 10 kilohertz to 20 as you go off axis by 10 degrees, but it's not really an audible thing. Maybe for some kids and some dogs, I don't know. Anyway, once the panel is together into one piece, you have the completed panel. The two panels in the floor standard are at slight angles relative to each other, so that the vertical dispersion isn't like an inch tall, which you would have from a 16-inch vertical aperture. So it's only yet about 10 or 12 inches in the vertical if you're sitting 8 or 10 feet away, but it's a good 2 or 3 people wide horizontally. So as long as you're sitting down in front of these speakers, you get a nice full frequency response, even if you're not right in the sweet spot. But if you are right in the sweet spot, this monopole dispersion from these extremely phase accurate speakers gives you a really amazingly accurate feeling of having that performance right in front of you, and you are there. You can hear if the ambience has been recorded with 2 mics or binaurally, you can hear that ambience around you. It isn't just coming out of the speakers. By the psychoacoustic illusion from the stereo images, that the ambience is everywhere and the performance is in front of you. And in some cases, wider than the speakers, and others not, depending on the okay, so the reason why those panels are in their own enclosure within the main enclosure, so the back pressure from the woofers doesn't affect them. They would not be damaged, but you don't want that membrane flapping from bass frequencies. And the reason that the cabinet is sealed is because of group delay. A cabinet that has a ported woofer will have a large amount of group delay at the bottom end, anyway, of the frequency range. And that winds up sounding like a completely separate speaker doing the bass from the electrostatics doing the treble. Electrostatics have practically no group delay. So you just have a much more responsive kind of woofing that goes and mates very seamlessly with the electrostatic. I know some people say that you have to use a line termination for the woofers, but I found that actually has plenty of group delay. It seems to work for our friend Sanders, but it's not the way I do things. I think that most people who hear these say that the woofers and the tweeters are so well integrated that you can't even really tell that it isn't a completely electrostatic speaker. I must be forgetting something, but okay, sound good at loud and lower volume. So this is the fact that the dynamics are very uniform causes the sensation that even the difference between extremely quiet and somewhat quiet, and the difference between loud and very loud, if it's the same number of dB going into the speaker at low levels, it's the same at high levels, and the overall effect is that the dynamics are invariant, that they sound about the same at low and high levels. But a nice thing about at high levels, now that we're using 8-inch woofers instead of 7s, and some other things changed, is that at high levels you can feel it. It's more of a concussive, it's maybe an exaggeration, but a percussive sensation to your body when you're hearing percussion, loud guitar plucks, and so on. So I guess there you have it.
Awesome, thanks for that great explanation. I've noticed other folks have mentioned sealed woofers tend to be better with integrating with panel speakers. So in that, could you elaborate a little bit on that? I mean, is it just the group delay of having added a port or something? Is that what causes the delay?
A port is a resonant item. It's deliberately resonant, and that resonance is at like half the resonant frequency of the woofer itself. So that extends the bass response by an octave, and then it rolls off very rapidly. And another thing that happens is below that frequency, the woofer is completely unconstrained. If you put a lower frequency into it, the woofer will just go limit to limit. You know, it'll hit its mechanical limits. And with a sealed speaker, there's an air spring behind that woofer that prevents it from exceeding its mechanical limits, regardless of what you put into it. That's helpful, but it's also easier to arrange a damping ratio. That's a technical term from physics. When you have an ideal damping ratio, like on the suspension of a car, when you hit a bump, it goes bounce and then it stops and you go ahead. If you're underdamped, it goes bounce, 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 bounce. And if it's overdamped, it goes thump. And we can arrange, and I think it's easier in general to arrange an ideal damping ratio when the speaker is sealed. And the effect on the sound is that the bass sounds tight.
Awesome. So I was wondering if you could change course here a little bit and help us understand some of the misconceptions about electrostatics. And I know we talked a little bit earlier about lacking dynamics and why that might be, and how having the panels on both sides prevents that from occurring, because you have forces, you know, front and back. Is that really what led to that myth about electrostatics lacking dynamics, was simply just that lack of a push-pull mechanism?
I don't know. Mainly they just didn't go very loud. And where they were going loud or being taken over. Okay, first of all, let's go all the way back to the KLH-9, which in my opinion was the first full range electrostatic speaker. It had, you know, 10 square feet of woofing, whereas the, you know, the ESL 57 from Quad came out at a similar time, and it was just a little thing, and it really didn't go loud at all, and its bass wasn't very deep. The KLH-9 was much louder, yet it only had a little, you know, 4-inch by 4-inch tweeter, and it just, they sounded great. We still have some here ready for, you know, upgrading and delivery to anyone who wants them, but they don't go very loud. And to get a sense of what people call a dynamic presentation, really a lot of it has to do with just how loud they go and how much impact you can feel from the music when it's playing loudly. I may be misconstruing completely what people mean when they say a speaker is or isn't dynamic, but that's what I take from it. And you know, Sanders speakers go extremely loud, and I think they're quite dynamic, and so are ours. I don't think I've ever heard a quad sound dynamic because they just don't have the oomph.
Could that be related to their lack of surface area?
Well, the surface area is important to get bass. And there are a lot of trade-offs that occur when you're trying to make a relatively compact speaker both get loud and have loud, deep bass. So you have to sacrifice some of the treble area to get more woofer area, and there are also speakers that are completely full range over the entire membrane. I think Sound Labs operate that way, and they use they say they don't have a crossover, but they use a circuit that is in essence a crossover to distribute the frequencies in a way that when you present them to the entire panel, it comes out flat, because otherwise it'd have a rising response from bottom to top. It's
What about power requirements? So I've heard that electrostats, you need to have very high quality amplification, they can handle, difficult loads down to 2 ohms, so forth, and that you need a lot of wattage. Is that necessarily true with your speakers, or I mean, you get around that because you have a hybrid design, or?
Yeah, it's partly because we have a hybrid, and the design has relatively small transducers. So these panels are in essence a capacitor. They function very differently from a dynamic speaker. Dynamic speakers are an inductor. At certain frequencies, they have a capacitive characteristic, and at others they're resistive, and at others they're inductive, and they're an extremely complicated load. An electrostatic is just a capacitor. To decouple that capacitance from the amplifier, if you have small panels, you can add a resistance, and that adds what's called a zero in control theory to the response, and makes it so that capacitance has a much lower effect on the what's called the phase margin that the amplifier has. Phase margin is something that when you violate it, the amplifier starts to oscillate. And before it starts to oscillate with a minor violation of phase margin, it'll resonate a little bit on each transient. And either of those conditions just sounds terrible. And the oscillation condition can sound, well, it can wreck the amplifier. It'll cause it to overheat, and it just won't sound right. So for that reason, an amplifier that can handle really low impedances is good for those large panel electrostatics that have a huge amount of capacitance and can't be decoupled with resistance, because that would kill the high frequency response. That's a different situation from when you have this tiny little thing going through the step-up transformers. Oh, that's another thing. The audio signal from the amplifier, the high-level power signal, has to go through a step-up transformer to get the high voltages necessary to pull the membrane back and forth. The higher that ratio, that ratio multiplies the voltage that's going in, but it multiplies the impedance of the transducer by the square of that ratio. So where we use about a 60-to-1 ratio, that's a 3600-to-1 ratio of impedance. So this little, it's about 100 billionths of a farad capacitance becomes about half a millionth of a farad, which is quite a lot. But sticking an ohm and a half in series with it keeps any amplifier from having a problem. And even at the top of the audio range, where a capacitance has its lowest impedance, our speakers are still under 8 ohms. So, any amplifier can do it. The reason you want a high quality amplifier is so that, any defect in the performance of the amplifier isn't heard, because these speakers reveal every nuance of difficulty that an amplifier might be having reproducing a signal accurately. I don't know if I answered the question.
No, you did a great job. Some of it, I'll be honest, is over my head, but I know there's a number of gentlemen on the call that are more technical than I am that probably can interpret it.
I'm sorry. I will rewind just a little bit to say what capacitance does is it becomes a lower resistance when the frequency goes up. So, our speakers might be a 40 ohm load at 1000 hertz, at a kilohertz. They're an 8 ohm or a 6 ohm load at 20 or 25 kilohertz. And one of those big panels will be, even at mid-range and slightly above frequencies, they might be 1 ohm or 2 ohms. And
oh yeah, very, very different.
Really difficult for an amplifier to handle.
Very good. All right, changing gears a little bit here. Have you spent any time studying the human ear and its functionality and how that, would apply to your designs? I mean, I've got a little window into your manual for the Valentinas, and it looked pretty detailed around, listening positions and things like that. So I'm curious to see, what your thoughts are on psychoacoustics and how we hear, because it sounds like you absolutely have taken that into account.
Mm-hmm. I have, and over the years I've learned more. It's such a huge field. It's hard to know where to start. For one thing, well, it can boil down to a large extent to philosophy. I mean, some people think that accurate sound reproduction is not a good goal. That people like their speakers to sort of be an instrument of their own and to have their own voice. I've even heard of people so-called voicing speakers, which, in my opinion, is a matter of adulterating the sound in some way. And I think ears like to hear as close as possible to the sound waves that were created originally and hit the microphone. One interesting thing is that all modern microphones are essentially little electrostatic speakers in reverse. There's a little membrane, there's an electrostatic field. When the membrane vibrates, it creates a voltage because it's working against the electrostatic field in that microphone. And an electrostatic speaker, it is just the opposite. So when you have one of them producing the signal and the other one reproducing the signal, it's only natural that you would wind up with a very accurate result that's pretty close to what was originally performed. Of course, there's no way that a speaker is going to sound like an actual instrument in the room, but you can get pretty close. And that's what I try to do. There's all kinds of stuff that's related to what's called the head transfer function, the distance between the two ears, the path that the sound from one speaker takes getting to the ear on that side versus to the ear on the other side, how much of the sound you would like to have delivered directly to each ear and not so much to the ear on the other side. Speakers that have very wide dispersion not only create a lot of local ambience, but they also present a lot more of the right channel sound to the left ear and vice versa. So and that interferes with the image, which is created from the stereo effect by having accurate phase response and a minimum of extraneous sound that isn't related in phase to the original direct sound that's coming from the speakers. I don't know. There's probably a lot that I'm glossing over or am at the moment forgetting, but I think those are important aspects.
So then in your setup guide, are you trying to direct folks to position your speakers in such a way that maintains the stereo image? Like you mentioned before, how sound arrives at each ear from the right channel and the left channel. I mean, is that really critical to setting up your speakers, or does that apply to every speaker?
It applies to every speaker, except with our speakers, you get a better result from doing the same thing as you would with any other speaker. In fact, our speakers, by not splashing a lot of sound onto the walls and really quite little onto the floor and ceiling, they're easier to set up. They don't involve the room boundaries as much as a wider dispersion speaker. So as long as each speaker is about the same distance from each ear, which happens automatically if you don't get it quite right and you just move yourself so that you're right in the center, it sort of takes care of itself. The frequency response is very strongly related to your head's vertical position within the listening window. It's best to be right in the middle of it. For this reason, the floor standers are back tilted so that they fire their sound up at the listener's head. And that tilt is really important because you don't want to be aiming them, at your neck or at your hair, best right at your ears. The horizontal aim is not nearly as important. Boy, I halfway triggered an important point in my head and it went away. Oh, the image. Something interesting that happens, even though these floor standards are, the bottom woofer is just, 8 inches from the floor, and the top woofer is at a different distance from the floor, but still below eye level. The impression of the image when these things are aimed right, especially with the tilt is correct, you hear an arc of sound that's substantially above the tops of the speakers. So they do not sound like the sound is coming up at you. It sounds like the sound is coming, at you from a large area ahead of you. Although at the speakers, that arc seems to find its way all the way down to the speakers. So if something's panned hard left or right, it sounds like it's coming from the middle of this, from the top of the speaker rather than from above it. Well, that was the thing I forgot. And then while I was saying that, I thought of another thing that I forgot. So maybe it'll recur to me.
Well, if it pops back in, please share. I just want to compliment you on your setup guide. I mean, I've never seen any materials that come with any speaker I've ever bought that provided so much information on how to optimize the placement of the speaker in the room to get the desired outcome. So phenomenal materials. I commend you.
I'm glad you appreciate it, because I leave out things like a little certificate of authenticity or fancy, felt or velour bag or anything like that. So, but we just ship them in cartons. What's important is they look nice and they sound good, in my opinion.
And I love that philosophy. So, what has been your more successful product? Is it the floor standers or the stand mounts? And then I notice you have active and passive versions of each.
Yeah, they both come in both versions. Oh, sorry, what?
So of the lineup that you have, because you have stand mounts and floor standers, and then you have actives and passives, what is the most popular product or most successful product?
Yeah, sorry, I did hear that, but it sounded like there's some other talking going on after it. It's probably my own echo. The floor standard is the more popular, and the active version by far is the more popular of the floor standards. There are some people who want to keep some amplifiers they've just recently spent a lot of money on, for instance, or just really love their sound, and also have some suspicions about the digital conversions and so on that go on, and the basically digital amplifiers that we put in our actives. And I can understand that. I like them both ways, but you get a lot more with the actives. Where do I begin? The woofers are more responsive because the cones are lighter, and I can get away with that because I can use equalization from the DSP in those speakers to push more power into those woofers at lower frequencies. We run them right through their resonant frequency, which some designers say is a no-no, but it works fine because they have that air spring behind them, I think. The bass goes deeper because we can make it go as deep as we want. The amplifiers have 3 different equalization presets that you can select from using the remote. This is the remote. It's just a Hypex remote. All the electronics are Hypex. Anyway, there are 3 F buttons, 1, 2, 3, and there's a 4th one that doesn't do anything. Hypex is taking suggestions as to what it should do, and I've failed mine. But anyway, those 3 presets will compensate for different wall distances. So if you want the speakers right up against your front wall, you can do that. You just hit F1. And if you want them farther out into the room, F2, and way out into the room, F3. So that's kind of nice because you don't have to pay as much attention as usual to where your speakers are located relative to room boundaries, and you can pay more attention to how they look or how the higher frequencies interact with the room, or get them out ahead of your stereo stand, which might be in between the speakers and act like a not very good diffuser. So there's that. The amps have the amps have a lot more power than necessary. They're 500 watts. There are 2 of them in each cabinet, but there's a limiter in the DSP. So I set the limiter so that you cannot apply any sustained power that's enough to damage the speakers. Yet on transients, the full power is available. So these speakers can reproduce. They have a tremendous amount of headroom for transients, and conserving transients is really critical to getting a sense of realism from the sound. I know some people aren't sensitive to it. I am. When the transients are getting clipped off by an underpowered amplifier, it sounds kind of more artificial to me than if all the transients are reproduced. This also ties into something about the panels. These panels have insulated electrodes, and not all electrostatics do. What that does is let you apply so much voltage to these things that the wires actually glow blue, purplish blue, as they're ionizing the air. When that happens, if it happens for long enough to actually ionize the air, the panel gets quiet because the air, when it's like that, is conductive and it just drains away the bias charge. However, if the transient is brief enough, these things can reproduce 6 dB more louder sound on a transient than they can steady state, which means that that extra power from the amplifier is not going to waste. It's going to taking advantage of these things' ability to withstand twice the voltage that they normally would be able to on transient. And that would be, just to be specific, things like hammer strikes, piano hammer strikes, drum whacks, guitar plucks, that sort of thing. When those get clipped off, it still sounds like music, but it doesn't sound as real.
That's amazing. So that each speaker has the 1,000 watts potential on tap.
It does. I set these up in someone's house. He has an antique house in Princeton. He's someone I work with. You probably have heard of him, actually, Edgar Chueri. His company is CCH, and he has like a really long name for his company, and I can never remember it. But anyway, my speakers work really well with this system, which creates a 3D sound field by doing crosstalk cancellation. What it does is minimize the sound that you hear coming from the right speaker and going into your left ear and vice versa. So you would think this would sound like headphones, but it doesn't. It sounds like the instruments are just like everywhere in the room. If you've got a binaural recording and there was a trombone straight off to the right of the pair of microphones, you'll sit there and you'll hear that thing coming from straight off to the right, even though the speakers are right in front of you. Anyway, I was demonstrating the speakers at his house, and he played something that he says, well, this one kills everybody else's speakers, so this is your acid test. So he plays this thing, and there's like huge drum thumps and loud crescendos and stuff, and every time there was one of these things, all the lights in the room would dim because his electrical wiring wasn't quite up to snuff. So yeah, it's actually a 1,200 watt power supply for the 2 500 watt amps.
That's amazing. I'm imagining, I'm just gonna throw this out there, which version, the passive or the active, in your opinion, sounds better?
Well, I think the active sounds better because it's possible to use the equalization to optimize the response of the speaker. I even can do a little something about, any speaker. Okay, I brought a couple of parts in here to show people. This is the baffle from one of the floor standers. And I designed these scoops in here to vary the distance between the transducer and the edge so that the diffraction interference would vary over a range of frequencies, and thus it would be minimized. There wouldn't be any one particular frequency that has a lot of diffraction interference, but there's still some. And with the equalization in these speakers, I can tweak that out. At least the part that's a spike. The dips, it's a bad idea to fill them because then you're imparting resonant behavior to the filter, and that wrecks transients. But you can push peaks down, and it's an improvement. Those minor but definite diffraction interference issues are present in any speaker, and of course in our passives, there's nothing I can do about them. I've recently made a change to the crossover in the actives. I had been using a fourth order crossover, which I thought was a great idea because then you've got minimum overlap without any side effects. Turns out, not really. There are side effects, and I could hear them when I was playing back a binaural recording of a thunderstorm, switching back and forth between first order and fourth order, and the first order just sounds way better. It improves slightly the imaging and everything on music, but it makes a huge difference on sort of neutral, noisy sounds like a brush on a snare drum, that kind of thing. Just sounds much better with the first order crossover. The passives have a first order crossover, and in both cases, to keep the woofers, okay, the crossover frequency is 500 hertz. If it were sharp at 500 hertz, there'd be nothing there to excite the cone resonances in the woofers. These woofers act very well as a pure piston below about 900 hertz, but then they start to break up. They're really bad at about 2 or 3 kilohertz. And with a first order crossover and nothing else, some people, I can't hear it, but some people have told me they can hear those cones. And if I play only the cones, I can hear it, but not together. But at any rate, I've taken the word of these people who say they can hear it and added a couple of more poles, but way up past the crossover frequency, so that it doesn't have any impact on the phase of the signal that you can hear. It just suppresses excitation of those resonant modes in the woofer, the breakup modes and the other things that a woofer will do when you try to get it to go at a higher frequency than it wants to. I do that also with the passives. I just have another network hooked in there that's at a higher frequency, and works well in both cases. I got the all clear from the people that could hear it before.
That's great. So you take feedback from your customer base and you're able to basically tweak the DSP.
Mm-hmm.
And is that,
as well as the design of the passive filters in the passive speaker. I take lots of suggestions. It would be foolish not to. Also, I don't have a lot of ego. At least my ego is strong. People return speakers every once in a while, and it doesn't bother me a bit. I give people a 30-day trial. There were 2 cases though that bothered me. One of them was a guy who sold my speakers and bought Maggie's because he likes that huge sound. He bought the big ones, and I thought, well, okay, that's what you like now. But then, that was a long time, years ago, but just, I don't know, 6 months ago, I saw a pair of our speakers up for sale on the music room, and I thought, I wonder whose those are. And I figured it out, and I got in touch with the guy, and it turned out that he had bought a pair of omnidirectional speakers, which are the polar opposite in every way of my speakers, right? Mine are directive, and they keep the local ambience to a minimum. Omnidirectional speakers excite the room as much as possible. And so you get this sound everywhere impression, and you also get a very big sound. The image is not so crisp. You won't feel like there's somebody like right in front of your face singing to you. but you get more of a sensation that that person is in the room singing, because, you know, the sound is bouncing off the walls, and it's as if a person were there with their own voice bouncing off the wall. So it's a different impression. It's, you know, I can't knock it. And over the years, periodically, omnidirectional sound has sort of gone into style and then gone out again. And I think maybe we're on the third or fourth wave now. I don't know. I think 71 or 2 was the first one I was aware of. 1971, I mean. Anyway, so that one kind of bothered me. So I thought, okay, what can I do? And we have a side tweeter on our speakers. It's been there for a long time. I call it the air layer. And for those people who feel like the sound is too closed in when there isn't room ambience, there's an outboard tweeter on each speaker that can be turned up too loud. And there's a continuously variable control from off to way too loud. And ideally, you'd set them so they don't really call attention to themselves, but they add sort of more of a sense of spaciousness. That wasn't enough for this person, and he really wanted a full omnidirectional speaker. So I decided, why not just add 2 more tweeters, one in back and one on the other side, so all 4 sides are tweeting. And if I could push that down to a low enough frequency, namely where the crossover is to the electrostatic, and then allow the woofer's natural dispersion, which is even at 500 hertz, it's 180 degrees. And if you don't go behind the speaker, it might as well be 360. Get all that going, and I just put some extra tweeters in little cardboard boxes and hooked them up to a passive. And it was a nice sound. So I didn't think it was practical to do that with the passive speakers, but it's very practical to do with the actives, because the same input boards and DSP boards that Hypex makes can control a third amplifier, which I can then use to drive these tweeters alone. So 1 amp for the woofers, 1 amp for the electrostatic, and a third amp for the these surround tweeters. I call them surround tweeters, but you know, omnidirectional tweeters. Cross them at 500 and use the DSP to make it so when you switch those on, it has no impact on the frequency response in the listening area, which in other, you know, it would otherwise add a whole bunch of trouble that you wouldn't want. And since there are 3 presets, no longer used for room boundary corrections. I mean, the speakers that have these extra tweeters would have to be set up in the usual way with usual considerations for where they're located relative to room boundaries, so that the bass isn't over or underdone. But when you turn the tweeters on, you get, like, I call it the sound everywhere option. I've decided to make it a product and see what happens, or at least an option. So you can get up and walk around the room and you have an even frequency response. This is called a flat power response by people who subscribe to the Toole, T-O-O-L-E, school of thought on speaker design, which several designers are strongly in favor of. And an omnidirectional speaker does this naturally. But adding the tweeter response to the regular response without any modifications to the direct response doesn't work, because I mentioned already the extra tweeting. Also, there's an issue of how big is the room. If you have a really gigantic room, that tweeting from those other tweeters is going to get lost in the room unless it's louder than it would need to be for a smaller room. So the 3 presets are sound only, Omni for a medium-sized, small to medium-sized room, and Omni for a large room. And you can switch between those 3 while you're sitting in your seat using the remote, and get 3 completely different, at least 2 completely different types of presentation from the same pair of speakers. I think it's an interesting idea. We'll see what people think of it.
Wow, I never even thought of that. Thank you for sharing.
It's brand new. We haven't even finished it yet. Well, it's finished, but we were trying to build orders. So last thing left to do, one of the pair is totally done, and the other pair still has to be final assembled. But it's close. I can show you that. I'll walk the camera around and show that to you in a few minutes.
All right. What about your headphones? I noticed you have some headphones coming soon.
They've been coming soon for 3 years. I'm really sorry about this. Whenever I get to the point where I think I'm about ready, it turns out I'm not, and then the speaker business picks up and I have to pay attention to that. And it's just very difficult to develop new products when you've already got some products that people are buying, and you've got to run a production area and do everything else. We're, a small company. I do a lot of different things. I just pretty much everything except the actual production, where there's some people here that do that with, unfortunately, quite a bit of my guidance. Anyway, the headphones are going to be unique if no one has scooped me by the time I finally come out with them. They're completely self-contained electrostatics, but they're electrostatic hybrids. If you want to get deep bass out of an electrostatic, well, in a headphone, I guess, first of all, like, good luck with that. But if you want to provide the signal to them, you need a large transformer, which you're never going to put into the can, the headphone can itself. I might dash out at some point and grab a pair of the headphone prototypes, but at any rate, putting the transformers and the bias supplies and the crossovers all into the headphones is a new thing, but the only way to do it is to have a woofer in there to cover the low frequencies. And at first I thought, okay, it's not going to sound so natural. There's going to be a problem with, transitioning between the two, and it'll be obvious that there's a woofer in there. But if you do it right, what actually happens is the bass sounds more natural and more palpable, because you've got a transducer in there that's able to move some air. It gets a bite into the air, whereas the electrostatic, it's more delicate kind of a situation for that. So having them both in there, you get the bass and the lower mid-range covered by a transducer that's really made for that, which doesn't really so much like to do treble and so on, which all headphones are asked to do. But the treble stuff, mid-range and treble, where you really need the most accurate possible reproduction, is covered by an electrostatic, and put together, it's a really nice sound. It's very similar to listening to our speakers, except the image is in your head instead of externalized as it is with speakers.
Awesome. Well, we're pretty much at time here, so what I would like to do is open the chat up and let folks bang away with a couple of questions, if you're okay with that.
Sure. I did want to just very quickly show a couple of things here in the office. These are the stand mounts. I'm not sure if they're clear, but this is the latest version of the stand mount actives. It has all the high-tech stuff on it. This is the control panel. Lots of inputs. This is the side tweeter control. And an interesting thing that it has is a full suspension. So built into it is complete isolation from the floor. It has, as you can see, a very low resonant frequency. So if you have a wooden floor, there'll be absolutely no coupling of the sound into it. And let me get this sort of re-aimed. This I put up onto a stool so I could rotate it. This is the first one of the new version that has the side tweeters and the back tweeters. So there's one side tweeter, back tweeter, other side tweeter, and no control for the side tweeter level. It's just there or not. And again, this is the heatsink for the amplifier and the input and control panel. All right, that's all I wanted to show you. I can come back and answer some questions now.
Yeah, I just wanted to give everyone who's been patiently waiting with bated breath to give them the opportunity to ask. So, we have the chat open. let's see what we've got here. I think you already answered this. One of these questions was from Kurt about is your DSP in the active speaker a HyperX unit?
The DSP, everything in the active is HyperX.
So the amplifier, the DSP, all of that.
And the DSP uses it's an analog devices Shark. It's very wide, deep bit depth and wide word length, and it's very fast. So it can do the work really fast with a whole lot of biquads in there. But I only use a few. Neither the woofers nor the tweeters need really any EQ to speak of. Just a little bit of, as I mentioned, the diffraction interference effects I do something about.
Awesome. Let's see what else we have here in the chat.
I want to mention that one of the advantages of the HyperX stuff is if you're fairly good with a PC, you can get in there and change the DSP yourself, or you can or as we develop new EQ preset files, we can send them out and people can load them on their own. So the sound of the speaker is basically upgradable. It's also true that the firmware in the HyperX stuff is also upgradable. It's all just done through a little USB port that's right there on the same panel with all the sound inputs. A little bit more.
Well, we give people a chance to ask questions in the chat. I'm going to ask you a question. What comprises your home system? I mean, is it just a pair of your active speakers, or I'm really curious. Like, what do you have? Anything special that you built custom for yourself? Or?
Actually, not. I just at the moment have a pair of our passive stand mount speakers, driven by. I don't even want to tell you. But I'll tell you, it's driven by a little 80 watt per channel topping amplifier, and a Bluetooth receiver that can handle aptX HD Bluetooth, which is the high resolution Bluetooth. It's got some latency, so I guess it's not supposed to be very good for pairing audio with video, but it does basically 24 96, and I stream a title stream from my phone to that little receiver, their hi-fi stream, which is CD resolution FLAC, and that really does it for me. When I'm home, I don't feel like getting incredibly super picky about every little detail of the fidelity. I just really want to listen to music. So that works. Here in my office, however, I've got a much fancier system that I occasionally listen to here, and that's a pair of the active floor standers and a really fancy DAC, and I play files of various resolutions from the computer through that DAC. It's a USB input DAC.
What DAC?
Oh, it has USB input, but it's an Exasound E32. It's the best DAC I've found. It's not even terribly expensive. It's $2,500, I think now. It used to be $3,500, but dealers were not doing they weren't performing, so Exasound decided to get rid of them all and cut the price by $1,000. So they have a number of other products as well, both DACs, streamers, servers, and so on. But their DAC is just amazing. It'll take just a plain old Red Book CD quality file and make it sound like it's analog almost. It's quite something.
And this goes into your actives. So this is interesting to me because you're taking a file from the computer, it's going through the DAC, and then you're putting it into the analog domain into a DSP.
Yeah, it's going from analog back to digital and then out the speakers. The this sounds, I'm busted, right? This is not the smart thing to do, but this is because I just happen to have actives available at the moment. When there is a pair of passives here that I can hang on to, which isn't for long, I run that DAC into an AVA, it's like a 400R, which is a hybrid amp. It does about 225 watts per channel, has MOSFET output devices, and 12AT7 tube input stage. So it gives sort of a little bit of that tube goodness along with MOSFET goodness, which is MOSFETs. The way they work is similar to the way a tube works. They're a voltage controlled current source, which is what a tube is, as opposed to a transistor, which is a current controlled current source. And anyway, that sounds quite amazing as well. So what can I say?
Awesome. So we're getting some questions here, and if you want, I can read them off for you, or if you want to just pick them out, it's totally your call. What's your preference?
From where I'm sitting, I can't read them.
All right, I'll go with this one. So this is from Rick. He says, if I were to raise a pair of ZA 2.1s off the floor and make the front of the baffle perfectly vertical, where would ear height be on the middle panel?
Actually, there are two in the floor standard, the ZA 2.1. In the old days, I thought it was smart to call the speakers 1.1 for the stand mount, which is one panel in a column of one, and the 2.1 is two panels in a column of one. And I had in my mind the idea that I would make a 2x2 array and a 5x1 array. Each of those things turned out not to sound very good, so I stopped there. And then somebody told me these numbers, ZA 2.1 is just too nerdy. I had to come up with names. So, I mean, you probably all know already, we call the 2.1 a Valentina now, but at any rate, we do have one customer who put we made him a special bass, or special riser that goes between the bass and the bottom of the cabinet that sets his speakers vertical, and he has them up on 18 inches off the floor on a shelf. And I think his head is 38 inches from the floor, his ears are, and he's imparted some tilt to them, but I'm not sure what exactly, and I haven't done the calculations to say what would be ideal, but I mean, I can say that this is certainly something you can do. It works nicely, and in fact, one advantage is that the height of the listening window doesn't change with distance. So, you can move forward, backward without the frequency response changing.
Yeah, that's kind of the motivation for that. I wanted to be able to get near field sound sometime by moving up as close as I wanted to. So I was thinking from some of the literature I saw, probably you want your ears slightly above the middle of that middle panel.
Yes.
Okay. Because the bottom, the risers they're going to be on are going to be on concrete. It's going to be very inert, so I'll gain some advantage there. Okay, thank you.
You're welcome.
All right, this next one is from John. Can you take account of room measurements to tailor the DSP, or is there an automatic way to account for room influences?
That's a really good and really big question. My experience with room correction is that the less, the better. Once you've got the bass humps pushed down, anything else you try to do, and then the entire bass region lifted to compensate for having pushed the humps down. Anything else that one attempts to do to deal with the room effects can cause harm, because those room effects have their own natural frequency response, and they're part of the room ambience. When you start to push those around, then you start to take away the naturalness of the room ambience, which has a secondary impact on the naturalness of the direct sound. So each time I've tried to EQ a speaker flat, I wind up feeling like some of the life has gone out of that music that I'm listening to. That said, if you would rather not use an external equalizer, you can get run the program that Hypex makes. It's called HFD for Hypex Filter Designer, and open up the file that's got the current equalization profiles in it, and tweak away. You use it to do whatever you like with the frequency response. I would shy away from making any alterations to the crossover, but even there, as long as you keep the frequencies the same, you can try different slopes and whatever.
Wow, that's incredible. So your speakers really, I mean, they're user modifiable.
To a dangerous extent.
Yeah.
But, you know, it's kind of a pain to use, but it isn't much of a pain. There are some foibles, as with any software that has a user interface that was designed by engineers and not, you know, basically field tested on regular people. But it's not bad. Oh, and I guess I didn't answer the entire question. It isn't automated. There is a facility within the filter designer for taking the measurements, however, and I got a hint of mint that maybe there is something automated that can be done within the filter designer, but it's not of interest to me, so I never really figured out how to do it. There's a manual, though. You can download both the manual and the software from the Hypex site. They have like 2 different sites. One is a DIY and one is a commercial site, but and I forget which one has the downloads, but you can find it. It's hypex.nl for Netherlands.
All right, so our next question is from Keith, and he says, can you please discuss caution about hearing due to lack of distortion at high volume, which is addressed in the manual?
Yeah, good one. One thing about electrostatics is they don't make any distortion, no matter how loud they go. When you exceed their limits, they just get quieter because of, I mentioned it before, ionization of the air and the air gap. So it is possible to have these things playing, you know, at a steady 100 dB with 110 dB transients on top, and not really notice it. What you notice is you can feel it in your chest and your belly, but doesn't seem loud. Your ears adapt, and just, you know, it is worth using a sound level meter just to check once in a while how loud you're really playing them. Because, see if I can remember, I think OSHA says you can listen steadily at 85 dB for 2 hours without doing damage, but that goes down by half for every additional 3 dB. So, so like at 84, you can only go for like, what is it, 40 minutes or something like that? And sorry, at 94 dB. And anyway, at 100 dB, you're if it's steady, a steady sound, you're in trouble within like 10 minutes or something.
Yeah, none of us want to damage our hearing.
And it's cumulative, so you might not notice each time you do a little bit of damage. That's the real problem. Like in high school, I was in some rock bands, and it was only a good session if your ears were ringing like crazy for like 3 hours afterward. And it seems like I got away with it, but I'll bet if I did that now, I'd lose my hearing really fast. So it's like probably another one of those things that, you know, you don't recover from as easily when you get older. I would just recommend, I think I actually published the OSHA guidelines in the manual. And if you don't have my manual, that stuff is online all over the place. So you can find out how much sound you can listen to for how long and before you get hearing damage. and just, be cognizant.
Also from Keith, he says, do you need access to an anechoic chamber for development?
Yeah, certainly. You really don't. It's nice to have, but it tests the speakers in a particular way that requires some engineering skill and interpretation to translate into what the speakers are going to be doing in a room, which is completely different from an anechoic chamber and is where people actually listen to speakers. A way to simulate an anechoic chamber is to basically take a speaker and put it on its back in the ground, make a hole and seal around it and put a microphone way up in the air. And then you get what's called a half field measurement. And there you only have the reinforcement of the ground itself, which can be calculated. Another thing that can be done is to take the speaker out into a large open area and play it as usual. I actually like to do that just to see what the actual floor bounce effects are, as opposed to what I calculate. And by the way, with the floor stander, having those two woofers at different heights gives you two completely different floor bounce frequency dips and peaks, so that they don't overlap, and you wind up with a lot less effect in those regards than you would with a single woofer in one position, that is. Anyway, back to testing. I test in rooms. I assume that, it's pretty easy to see from a frequency response what's going on from the room versus the speaker itself. Also, if you're taking the measurements rather than with pink noise or a swept sine wave, if you use a, I forget what it's called, there's a random noise generator. It's stochastically uniform, and you can use that to create an impulse response. And then you can gate the impulse response to eliminate the part of the response that becomes later than the direct sound from the speaker, which is, it's obviously the room, and then depending on the frequency or except which happens much. So that's one reason why I like to take the speaker outside to find out what the response is actually. A floor bounce, bring the speakers back in, response, gate the impulse response so that the room effects are eliminated from the response, and then I get a frequency response that's true to the speaker itself. And this is something anybody can do. The software I use for an impulse response is called ARTA, A-R-T-A. I think it's from a German guy, and it's really great, easy to use. You hardly even need to look at the documentation. It's really fantastic.
Also from Keith, says, I've never used air on my Valentinas. Should I? I'm not even sure what that means, using air on them, but perhaps you would know what that means.
I'm sorry, what was the question again?
He said he's never used air on his Valentinas. Should he?
He probably means the air layer, that side tweeter. That's a lot of people don't use it at all. I don't use it because I prefer that, strictly direct sound. And a lot of other people do use it. It's a matter of taste, and actually it matters what the recording is like. Some recordings give you a sense of complete envelopment without those air layers. You feel, and you can hear actually sound which seems to be coming from all around you, even though it's just stereo effect that is ambience that's been conserved by having been recorded with very good phase accuracy, and of course reproduced with very good phase accuracy, which is one of the good things about these speakers. As far as how to experiment with that air layer, I don't turn mine up at all, but if I were to, what I found is that they interfere minimally with the imaging if they're set at like minus the control is calibrated from -infinity to 0, and the first couple of grade graduations, as you turn them up, are like -16, -14, -12, -10, and I think -14, -12 works well in a small room, and you might go higher in a big room. And if you've got an asymmetrical room, like where one side of the room is like wide open and the other side has a wall nearby, you can set them to different loudnesses to compensate for that. So keep whatever you like.
Okay, well, that was the last question I see here. I'm going to give everyone, you know, about a couple of minutes to continue. You know, if you have questions, please write them into the group chat. If not, then we'll adjourn. So calling once, calling twice, calling 3 times, and I see someone typing. So
Sold to the late paper.
I sure can't wait for this pandemic to end, because I really would love to hear your speakers, by the way. And I happen to know that there's a couple of club members that possess them, and maybe one of them would be kind enough to invite me over to their home.
Yeah, there's someone, I've unfortunately forgotten the name. It was some years ago. Someone from your area came out to San Diego to watch the presentation I gave out there to the San Diego Music and Audio Guild. And he wound up eventually buying a pair, and I forgot his name, but I'm pretty sure he's one of your members as well. If you're out there, hi.
All right, folks. Well, I guess that would be it. No more questions. David, thank you so much for joining us today and explaining everything about your speaker designs. I'm just so amazed by all the thought and engineering that has gone into your products. I had no idea that they were as sophisticated as they are, even to the point where you've decoupled the stand mounts from the stands in a way that reduces resonance. It's just very impressive design and thoughtful to look at the minute details.
Well, thank you. I like having that sort of thing be appreciated. But I know, you know, if you look at them, they just look like speakers. And that's okay with me. Most people can assume that there's not that much going on. But when they hear them, that's when the magic happens. Just one thing, Paul, I forgot to turn on the recorder on my Skype. Can you send me the file?
I will. I've recorded it, and I'll be happy to send you a copy. We typically, you know, take the final and edit it, and then we can share it with you.
Cool.
So, but if you want the gross file too, no worries about that. But
yeah, I guess, yeah, just the raw file would be good, at least to begin with, and then whatever you come up with is probably going to be what I come up with if I try to edit it. So that'd be good too.
All right, sir. Well, thank you so much for your time today. I hope you have a fantastic evening, and thank you for everyone that joined us on the call.
Yeah, thanks everybody who came. That's really nice. It's really great to see you all out there. See you again one of these days. Maybe I'll come out there in person once this is over.
That we would love to see.
Right. Bye.
Bye-bye.